Hi friends, welcome to my channel. I hope everyone is doing well. Today we are going to solve another very popular and recent coding problem on Leetcode. It's 3208 alternating groups 2. So this is a medium complexity array related coding problem. So we are going to understand this problem with some examples. I also created some example for you guys so that you can easily understand the logic as well as the solution how we can solve these kind of problems. If you are new to this channel, please subscribe to this channel now. Your subscription is really valuable and important for the channel. It really helps and supports this channel. So let's start. There is a circle of red and blue tiles. You are given an integer array, colors and integer value k. The color of tile I is represented by colors of I. Okay. So colors of I, 0 it means that it's red and 1 it means that it's blue. Okay. An alternating group is every k contiguous tiles in the circle with alternating colors. Each tile in the group except the first and the last has a different color from its left and right tiles. So that is called as alternating group. Return number of alternating groups. Note that since colors represent a circle, the first and last tiles are considered to be next to each other. This is an important point to note, right? So it's a kind of a circular array, you can say, basically. So this is one example. So 0 1 0 1 0. So if you draw a circle with the colors they said, right? So 0 is red, 1 is blue, right? So this is how the circle will look like basically, right? And k value 3 is given to us. So we want to find out how many alternating color circles are here, alternating color groups. So they have nicely highlighted it. So you can see that this is one group 0 1 2. So they highlighted it. It has an alternating color, right? 0 is red, 1 is blue and 2 is red. So this is one group. Then 1 is blue, 2 is red, 3 is blue. So this is another group and this is another group, 2 3 4, correct? So these are the three groups which are having alternating colors of size 3. So size k is given to us. Okay, size k is given to us. So this is another example where you have 0 1 0 0 1 0 1 as the array, which is a circular array like this. If you draw a circle, it looks like this basically. Okay, and k is equal to 6. So we want to find out k 6 with k 6 value alternating group, right? So they have nicely highlighted it, the groups. So if you go from one like from 3 to 1, right? 3 4 5 6 0 1. So this is one group, alternating colors, right? This is another group, how 4 5 6 0 1 2, alternating colors, right? 4 is blue, 5 is red, then blue red. So it's another group. So actually we only found out two such groups here, right? So that's what we want to find out, how many such groups are there. Okay, so this is another case 1101 where you don't really have any alternating group of when k is equal to 4, right? Because this C you cannot find any alternating group, so you have to return 0 in this case. Colors dot length is between 3 to 10 raised to 5 inclusive, so it will be a very large array as you can see, and the colors will be only 0 or 1 in that array, and the k value will be between 3 and colors dot length. Okay, so k value can be also very big actually, right? So these are the constants. So I hope you are understanding what the problem is asking us to find out. So I created another example for you which is similar to the first example, but this is a little different. So now again this array is given to us, right? This array is given to us, k value 3 is given to us. So what we did here is we took this array. So this is the array that is given to us, right? This is the array which is given to us, and what we did, we appended that array with the same array, right? Why? Because we, this just to show you, because it's a circle basically. What it means is after 1 you again come back to 0, right? Like this. So you after 1 you back to 0 again, 1 0 1 0 1, right? So it's a circular array, right? So I just put that same array again, okay, just to show you in this example. Okay, so now what we want to do is k value is 3 is given to us. We want to find out here now how many alternating groups are there. So 6 is the answer here. So how that 6 came, so let me show you here, right? So the alternating groups, so that we can also discuss the approach as well. So here is one alternating group, right, that you can see here, 0 1 0. This is alternating group, correct? Okay, this is another alternating group, right? 1 0 1, this is another, because k is 3, right, size is 3. So we found two groups so far. So this is sorry, this, let me choose another color. So this is another group that you are seeing here. I hope you are following me. 0 1 0, these are alternating colors, right, blue, red, blue, like this. Okay, so three groups we already found. Let us go ahead and try to find out more groups. So this one is the fourth group. 101 is fourth group, right? This is fourth group. Then this 010. Now see, now we are coming and using this next array that I appended, right? So 010, so that I can show you that this is alternating group basically, right? 010. That's why I appended that array here, okay, to the original array. So now you can see that this is alternating group 010. So we found 5 groups so far, right? 5 groups so far. Now after 5 groups, this is the last group that I will show you here. This is the last group, right? 101, right? 101. So because it's a circular array basically, correct? Okay, so now the total 6 groups we found, right? And I shown you how those 6 groups came basically, right? Okay, so now we understood that there are 6 groups, but now how will we actually find these problems? So have you noticed one thing? What we did here, we are actually doing a sliding window basically, right? So sliding window algorithm we can use here. It's another very popular algorithm to solve these kind of problems. So what it means is that we'll create left and right pointers, and we will keep moving the pointers, right, so that we can start finding the window of size k, right, size k. So size 3 window. So for example, first we will start from here and we will go here, and this is my window, right, and this window has alternating colors, right, 0 1 0, right? So when they are alternating colors, and when my window size reaches k, right, reaches k, so now my window size is k, which is 3, and it has alternating colors. What it means for us, it means that I found out one alternating group, so I will count it as one, right? So I found one group basically. Okay, I will keep expanding this window basically, right? I will keep expanding this window. So what it means is I will go to the next, basically we will now look into this window basically, right? This window. So because now we want to find out if there are any more groups basically, right? So 101 is another group, so we will increment our count. So we found two groups now, correct? We found two groups which are having alternating colors. Now our window will keep moving. Now we will move here, right? And 0 1 0, right? So this group is again alternating, right? Because this 0 is coming inside the window, right? So we will keep expanding this window as long as the colors are alternating, right? As long as the colors are alternating, we will keep expanding the window, and we will keep counting how many windows are there basically with the alternating groups, right? And if there is a, let's say, so now you understood how it will work, right? So where is the last window you will get? This is the last window you will get basically, correct? Last window is this one with alternating colors, 101, and that is the sixth window. So that's how you will find 6 windows basically. So 6 is the answer. Okay, but what if, let's say after this one, let's say this one is 0 for example. Okay, so this window you already found, right, which is alternating colors. Okay, and when you go and take this 0, this is not alternating color, correct? So it means that you cannot, this window will not be possible, right? This is not a possible window basically, because these are not alternating colors. So in that case, what we will do, we will keep our left pointer here. Wherever there is a mismatch, we will move our left pointer here, left, right? Left pointer. Okay, and then again we will start our sliding window from that point, right? So again 0, you will go here, again 0 and 0, there is no alternating, right? So your left pointer will go here, right? Left pointer will go here, and right pointer will also go here, right? Right pointer will also go here basically, correct? Again you will start from this point, right? Again now you find 0 1 0, which is alternating. It means that this is your valid window basically, right? So whenever you your alternating thing breaks basically, you will have to just shift your left pointer there, right? Because there is no possible window basically, because alternating thing is breaking. For example, 0, when it 0 comes here, there cannot be alternating group including this 0, because this 0 and 0 are not alternating, right? So this is the way we can use a sliding window algorithm to solve this problem. So I hope it's pretty clear. So I will explain you more once we go through the Java code, but this is what we are going to do. Okay, and the thing is, since we are using a sliding window algorithm, we are going to go through this array only once, only one time, right? One time. So this is the important thing. So this is a very, very efficient solution, because you are going through the array only one time, right? Which means that your time complexity for the code is going to be order of n, right? Order of n, because you only went through one time in that array, right? So that is the most important part. So when you have a very, very large array, still your solution will be very efficient. Okay. So let us go ahead and take a look at the Java code, then it will be more clear for you what we are going to do. So number of alternating groups is what we are implementing. Colors array is given to you, k value is given to you, right? Okay, this one is going to return int, which is number of alternating valid groups basically, correct? So n is the colors dot length that we read here, and we will create one variable to count the alternating groups, which is 0 in the beginning. Left pointer is 0, index 0, correct? Left pointer is at index 0 in the beginning, and right pointer we will start moving from index 1. Very, very important. Okay, so your for loop starts right is equal to index 1. Right should be moving until n plus k minus 1 right plus plus. Why that n plus k minus 1? I will tell you. So let us remove all these colors so that I can tell you what we are doing there. So what I'm trying to say is, if you have k value is equal to 3, it means that your last window is still possible here, right? This window is possible, but now this 0 and 1 are actually not there in the array, right? So these 0 and 1 are not actually there in the array. This is just appended there to the original array. So we will use a mod operator for that, right? So that you can go back to this 0 and 1 basically, correct? So that is why you have to, for this last window, you have to keep checking for these two elements also, right? Because this last window will go out basically, correct? You understood this, right? Because this 0 and 1 is out of the window basically, but they are still valid. It means that basically what I'm trying to say is that for this last window, you will take this one and you will have to go back to this 0 and 1. This is how you will form your window basically, right? And your window will be 1 0 1, correct? And you have to check if that is alternating or not, right? So that is why in this for loop we are taking right is less than n plus k minus 1, and here we are checking if the alternating thing is breaking or not basically. If alternating things, right, colors of right mod n, right, right mod n is equal to colors of right minus 1 mod n, right? If it happens, right, if it happens, it means that you are having same color, so you are not having alternating color, correct? It means that you are having a same color, which means that you are not having alternating color. In that case, you have to put your left and right pointer to that position where it is breaking, correct? For example, I shown you right in that example before. So for example, if this one is 0, let's say, then your alternating is breaking, because this 0 and 0, right? So they are not alternating, so you have to move your left and right pointer at this position, correct? Left and right you will move there. That's what I am saying basically. Okay, after that, if it's not breaking, then you will have to check if you found out that valid window size or not, right? So right minus k plus 1 is greater than equal to k. It means that you found out a valid alternating window basically, right? When you found out a valid alternating window, you are going to increment your group count by 1, correct? You understood this, right? So you found alternating window, then you have to increment it because you found one more group basically, right? So you will keep looping in this for loop, and you will keep checking this way, right? And whenever you find out a group which is valid, you will keep incrementing it. At the end, you will have to just return that alternating group count, and that one should solve the problem, right? So this is a sliding window algorithm. Okay, So now let us talk about the algorithmic complexity for this code. So time complexity for this code is going to be order of n. Why order of n? Because of this for loop, right? This for loop. So it is a order of n time complexity. Okay. After that, let's talk about the space complexity for this code. The space complexity for this code is going to be order of 1, or this is also called as constant, because we did not use any extra data structures for the space here. So only couple of variables, and variables don't count over space. So it means that this is a constant on space solution. Okay, that's what you can tell to the interviewer. So let us go ahead, give it a run, and make sure this code compiles and works correctly. And so we are getting correct answers, as you can see here, right? So these are all correct, and this is the example that I just shown you, that I created for you guys here. So here we are expecting 6 as the answer, and 6 is the correct answers. Okay, so submit this code now to the Leetcode. Make sure the code gets accepted by the Leetcode. And as you can see on the left side, the code is successfully accepted by the Leetcode. These numbers are changing, so I am not very sure about these numbers, but we will try to resubmit it one more time for you guys. So you can see it's 57.52% faster than other submissions, which is a pretty good code to solve this coding problem. 3208 alternating groups 2 on Leetcode, a medium complexity, quite popular and recent coding problem. So I wanted to show you this sliding window technique, how we can apply on this problem to solve this problem. And I hope that this example that I explained you here help you understand this problem in an easier and better way. And if this example really help you understand this problem, then please give it a thumbs up to this video, give it a like to this video, subscribe to this channel. Your subscription is really valuable and important for our channel. It really helps and supports the channel. Guys, it takes lots of efforts to create these videos, to come up with these images and examples and explain these examples. So it takes a lot of creativity and time. So if you really want to appreciate our efforts on this, then try to be generous and give it a like to the video, as well as subscribe to our channel. Click on the bell notification icon button right away, so you won't miss any upcoming interesting videos like this one. On this channel, we create content and videos to help others in their interview preparation, as well as helping them with their data structures and algorithmic learning, by showing them how to apply different algorithms and data structures on solving different varieties of coding problems that are previously asked by big tech companies. The important playlist that you should not miss from this channel includes graphs, matrices, binary search trees, binary trees, how to use and apply binary search, dynamic programming, recursion, memoization to solve different problems, as well as BFS and DFS on graphs, matrices, and trees. The data structure playlist includes stacks, queues, priority queues, min heap, and max heap. So go through them. You are going to learn a lot by watching those videos, as well as they will definitely give you a good preparation if you are planning to take interview rounds. Share these videos with all your friends, so they will also watch these videos and learn from these videos. Keep learning, keep coding, and keep solving more varieties of coding problems. And thanks for watching this video, and have a great day ahead.